All right. We are now recording. Let's see. Lindsay, let's do math. Okay. Like I said, I would start with this bottom row because it's actually easier to figure out what it's asking for, I think. So first question is, how many of these films won an Academy Award? So that would be anything in this A circle. So you would be looking at those numbers. So that is 4 plus 5, which is 9. And again, when it says how many, you're just giving a number. You're not giving a probability. You're not giving a fraction. This one says how many won a Golden Globe. That would be everything in the G circle. So that would be 5 plus 13, which is 18. Questions so far? Okay. The last one says how many won an Academy Award or a Golden Globe? And or is, what does that mean? Anybody? Oh, good. Union, right? Union. So that means we're going to do both of them together. So A or G would be all of that. Make sure you have the right thing shaded. So that would be 5 plus 13 plus the 4. Which is what? What'd y'all get? Nobody got it? 22. Okay. Questions on those three? All right, good. Now go back up to the top here, like we said at the beginning. I would shade one in one color, one in the other, and then look where they overlap. So the overlap here is what this intersection means. And the overlap of A and not G is this green section here, which would be 4. So if it says size, again, you're just giving the number, which is 4. Okay? Davis, you good? I'm good. All right. This one, again, I would start with this. Let's shade A. And then we're going to shade not G. Oh, it's the same question, right? Did y'all realize that? I forgot. Not G. That's fine. We can practice. Is everything here. But this time it's asking for the probability. Okay? So you're going to take that intersection and you're going to put it over the total, which is it 100? No. 92. And that would be your probability. So yes, you could simplify it. I think it's 1 over 23. Thank you. That would be the answer. So there's a 1 in 23 chance if you picked a random movie out of this list that it would have won an Academy Award and not a Golden Globe. That's what that means. I know that's not a raise your hand, that's a stretch. All right, so here is how this is working. When it's asking you for the size, we are taking what's in A, right? And we're taking what's in G, which was this right-hand circle, and we're adding them together. But when you do that, as you're adding them together, did y'all notice that in this one and this one, they both had a 5, right? They both have that intersection. So if you're adding A plus G, you're going to end up adding that 5 twice. So what you have to do is at the end, you have to take that intersection and subtract it. So here's the deal. If you're not using the Venn diagram, this is how you would do it, right? When you look at the Venn diagram, it's easy to see it. But later on, you'll see we'll get to where we're just getting numbers and not a Venn diagram. So you're going to have to make sure you don't add that overlap in there twice. Okay? So this is just kind of just summarizing what we were doing in there. If you don't have a Venn diagram, then here's the formula you're going to use for that. We're going to write that in. And you're going to use this a lot because there's going to be questions a lot of times where you don't have a Venn diagram. So Connor, make sure you write this down. Okay. The probability of A or B, because remember union means or, right? Is going to equal the probability of A plus the probability of B minus that intersection. Okay, so if I don't have that Venn diagram and I can't see those specific numbers to add up, right, I got to be careful that I'm subtracting the intersection. The intersection is notated as A and B. It looks like that. Now, if you have the Venn diagram, then you can see it, right? But if I didn't, then it would be this 9 plus the 18 and then minus that 5. That would give me the answer. You just got to make sure that you don't add it in there twice. Okay, it'll make sense the more we practice with it. Just please remember this formula. Okay, you will use it a lot in this unit. You should be using it. This is the union formula. If I say, what's the formula for union? This is the one. Or. If you see the word or, you should just go ahead and write this formula down because you're probably going to use it. Okay, so. One other thing we need to talk about is not. Okay, not A. We talked about this last time. You'll see it with an apostrophe, right? That means not A, but you will also see it like this with a bar over it. That also means not, okay? So just be aware, sometimes you'll see a bar or an apostrophe. And not A is everything that's not in the circle that is A. So it's all of this stuff out here. My highlighter's too fat. So just remember that if you have nor, y'all have heard either or, right? You're supposed to say neither nor, but no one says that. But in math, we got to know that's what that is. Davis, you with us?
I'm good.
Okay. Archer, you good? Okay. Neither A nor G means not A or G, right? Are y'all with me? It's kind of the same. Okay. So the way you'll see it written is A or G, but not that. Does that kind of make sense? A or G, but not that. So you would say neither A nor G. It also might look like this with a bar over it. That also means not A or G, or neither A nor G. You might even see not A or not G. That means the same thing too. Okay. That would basically be everything that's not in A or G, which would still, which would be this outside part. Just to make sure we realize, because those are going to pop up when you're like, what's that bar? And then it'll be like, oh yeah. All right, we're going to go back to this formula here, and we're going to show how we're going to use it in just a second. So hold on to that. Right before we do that, we're going to talk real quick about what's mutually exclusive and what's overlapping, because that's going to come up in a second. Basically, mutually exclusive would be like if I said, how many freshmen are also seniors? And you would say, what? You can't be a senior and a freshman at the same time, right? So that's why they don't overlap. And if you're a senior who's failed every year, you're technically not a senior. You're a freshman.
Well, what if you're like a senior and you're also like a freshman in college? Because you're like dual.
You can't, you're not really a freshman in college. If you're enrolled in high school. It's a good try though. So basically mutually exclusive events have no overlap. Overlapping events obviously have an overlap. So that might be being a freshman and let's see, we did sports last class, so maybe being in band. So some freshmen are in band, some people are in band but not freshmen. Some people are freshmen in the band. So there's overlap there. All right, here's where our formula is going to come into play. Notice that we do not have a Venn diagram, so I'm definitely going to use my formula. Okay. Here we have a deck of 30 cards. It has 10 red cards, 10 blue cards. That's not blue. And 10 yellow cards. The cards are labeled 1 through 10. All right. If we draw a card from the deck, what is the probability you will get a red card or a yellow card? How many cards are we drawing from this deck? Nope. What does it say here? A card.
Oh,
1. It's important to know how many, right? 1 card. So, are these mutually exclusive or overlapping? Red card or yellow card? It's a tough question. I'm only taking 1 card. Can I get a red and a yellow card at the same time? No. So they're mutually exclusive because there's no overlap. Now, what if I said the second one, could I get a red card or a card labeled 10? Those are overlapping because there are cards that are 10s that are not red, right? And there's some that are red that are 10. Like those overlap. Okay. Now here's where the formula is going to come into play because it says what word right here? Or I'm going to use my union formula. Okay. And we just learned it. Probability of A union B. And every time you do this, if you write this down, you'll remember it. So you need to write it down because then it keeps it organized. I promise you it'll help. Probability of A plus the probability of B minus, what do we take away? The middle, the intersection, right? So it's A intersect B. That's what we take away. Because you'll see why in a second. All right. So what is event A in this case? We're looking for red or yellow. So probability of A would be, come on, one note. Event A, or you could call it probability of R for red. It doesn't matter. What is the probability of getting a red card? There's 10 of them. 10 out of 30, right? Possible over the total number of outcomes. And then the probability of B, which in this case we're calling event B yellow. What's the probability of pulling a yellow card? 10 out of 30. And then you're going to take away whatever overlaps there. So what's the probability of a red and a yellow card at the same time? None. In this case, it's none. It usually will not be none, okay? So just get used to this. You'll see in the next one. So then you just add it up like they're fractions. 10 plus 10 is 20 over 30. So the answer is 2/3. So that means if I pull a card at random there's a 2/3 chance it will be red or yellow. Which makes sense because there's 30 cards. And they don't overlap, so I don't have that overlap to subtract. Now, what happens if they do overlap, like this second one? Okay, again, it says or, so we're going to use our formula. Probability of, we can use R. Is that confusing y'all if I change it from A and B? No? Okay, so red or, should we say T for 10? Okay. Still the same formula. Probability of the first one plus the probability of the second one minus the what, Connor? What do I subtract? What does that symbol mean? Nope. Intersection. The intersection. I'm subtracting the intersection. And you'll see why on this question you need to do that. All right, so the R stands for red. Probability of red, we just did it in the last question, was 10 out of 30. Agree? Yes. All right. The second part is the probability of a 10. How many 10s are in this deck of cards? 3. The cards are labeled 1 through 10. Each color has 1 10, so that would be 3 out of 30. We're adding these. And then we're subtracting the intersection where they overlap. So how many do I have that are red 10s? I have 1. So I'm going to subtract 1 out of 30 because it's a probability. Y'all with me? What did we add the red 10 in this first group? Was there a red 10 in that group? Right here. Was there a red 10 in there? Yeah, because they're red cards, right? Was there a red 10 in this second group with the 10s? Yeah. We added the same card how many times? We counted that same card twice. Are y'all with me? Let me say it again. Davis, you listen? Connor? We added the red 10 in with the first group. We added the red 10 again when we counted the 3 10s. So guess what? We have to take out one of those 10s. Does that kind of make sense? We're taking out that second time that we counted it. Okay? That's why we use this formula. So that gives us 10 plus 3, which is 13 minus 1. So we have 12 out of 30. And you can simplify that to 2/5. So 40% chance, 2 out of 5, that if I pull one card out, I'll get red or I'll get a 10. Could I get a red 10? Yes. Could I get a yellow 10? Yes. Could I get a red 2? Yes. All of those are what I'm looking for. Okay. All right. Now I'm going to throw a monkey wrench in here. What is the probability that you won't draw a blue card that has an even number on it? Oh, goodness. What are they asking for here? Probability of blue. Is it blue or even or blue and even? What? And even, right? Because it has to be both blue and even, but not that, right? So my suggestion is start getting used to translating these blue and even, but not that. Y'all with me? How many blue even cards are there? Well, they're numbered 1 through 10.
5.
So there's 2, 4, 6, 8, and 10, right? So yeah, there's 5 cards. that are blue and even. So how many are not blue and even? 25. But it says probability, so it'd be 25 out of 30. Okay. Then you would simplify that to 5/6. But same idea. That one's not as bad. Now it doesn't say union, right? So did I use the union formula? Nope. All right. I messed this one up last class because we had the Venn diagram, then we didn't. So we're going to do this without the Venn diagram first. So practice the formula. Okay? So, survey of 100 people, 2 questions were asked. Do you drink coffee? 53 people said yes. 67 people said they drink soda. 28 people said yes to both. All right. Are these mutually exclusive or are they overlapping? Okay, that's easy, right? They're overlapping. Now here's the kicker is, do you drink coffee? 53 people said yes. So the probability of coffee would be 53 out of 100, right? That makes sense? I'm kind of translating what they're giving me. The probability of soda, trying to use a different color, it's not letting me. Probability of people drinking soda is what? 67 out of 100. Good. And then this one is 28 out of 100. What is this one called? The probability of what? Soda and coffee. So how do I write that? So it's P of soda, coffee. What symbol goes in the middle of those? The N looking one, right? The upside down U? Because it's intersection. So that's and. So it's soda and coffee. Do y'all get that? It's really important to be able to translate English into these notation. All right, so once I have that, it's asking me how many people drink coffee or soda. And or means union. When you hear or, you should think, oh, union, okay. Can I get my marker to change? So we're going to use our union formula. Look how handy that is. If I can get my thing to work. So again, when it says or, just use the formula. It's a probability of coffee or soda would be probability of coffee plus the probability of soda minus the intersection of coffee and soda. I'm just rewriting the formula. I have not done any math yet, right? I'm just writing the formula for placeholder so I know what to plug in. What's the probability of coffee? Well, guess what? We just wrote that up here, right? We just did that. So probability of coffee is 53 out of 100. Probability of soda was at 67 out of 100. And then we have to subtract the intersection because we already added in with the coffee drinkers. Some of those people drink coffee and soda, right? And then in the soda one, we already added in those people that drink coffee and soda. So we're going to take them out. So we can take this number right here and plug it in. 28 over 100. It's the wrong color. See how that formula comes in handy now? So what does that equal? Somebody? How much? Yeah, that sounds right. 92 out of 100. And then you would simplify that. I think it's 46 out of 50. No, that's not right. What does it simplify? 23 over 25? Okay. So pretty highly likely that somebody drinks either coffee or soda, right? They don't have to drink both. Now, if you want to fill out the Venn diagram, you can do that as well. My suggestion, listen up. I said this on Thursday. When you fill out a Venn diagram, if I were you, I would start with the intersection and write that in there first. So let's write that in. So 28. So now for my coffee, let's label this. Coffee is on the left. Go ahead and fill out the Venn diagram and answer the last question. Let's make sure we remember how to do this. This left, coffee, soda. Start with that intersection. It will help you when you go to fill out the diagram. Let me make sure that you got it right. Okay. Make sure it says how many, you just give the answer. That's a probability. So if it said what's the probability, then you would get the fraction. Yeah. Once you're done with that, you can start on your homework. It's a lot of different types of questions. It's really good practice, good for the stuff. You get it? Are you coloring? Okay, that's fine. Enjoy the coloring.
You have to, would you subtract from this, or would you just write that?
Yeah, so you subtract because coffee would be the full circle. And you add it to 3. Yeah, you're right. There you go. No, it's not. It's not coffee or soda. Neither of them. There you go. You get it? Get a number. Okay, good. Okay, so the reason I wanted us to try this is because of filling out this diagram. If y'all don't remember this, it's been a couple days. Make sure when you fill this out, think about this for 1 second. When it says probability of coffee, 53 people said yes. Remember, that's the entire circle that says coffee is 53. You already have 28 in there. So you have to subtract. 53 minus 28 is how much? Somebody? 25? That's what you write right here. Okay? So you don't put 53 on the left. You already counted 28 of them. And then on the right, soda, there are 67 people, but you've already counted 28 of them. So you have to do 67 minus 28, which is that 39? 39 would go right here. Okay? Then you add up the numbers that you see, and I think you get 92. So that would give you 8 people on the outside that do not drink coffee or soda. Now, I saw some people were writing it as a probability, and that's awesome. So it would be coffee, union, soda, but not. Right? Now, here's the trick. It didn't ask you for probability, it asked you for how many. So you wouldn't have the P in the front. But you would still have, that would be the notation for it. Coffee or soda, but not that, right? Neither coffee nor soda. So when you go to shade it, some people I saw were shading it, which is totally fine. It would be everything on the outside of the circles, right? Which was how we got that 8. It would be everything outside. So lots of different ways to get to the answer. But basically, when you fill out those Venn diagrams, make sure you account for that overlap in the middle when you're filling it out. Okay? Any questions on any of that? Okay, the homework is a really good kind of sampling of a lot of the different stuff that we've talked about so far in this unit. So please make sure you do it and you practice it, okay? It provides you with some diagrams that you can shade. I would suggest that you use those. They're very helpful because, like I said, you're going to have to go from shaded to Venn diagrams to just writing it. And you got to get used to how to translate, right? Probability of pizza or credit card would look like that in notation. If you get down here where the diagram is, they're asking you to shade first and then look for the probability. Okay, that will help you, I promise. Hey, and they even threw in one with 3 circles for you. Yay! All right, let's stop the recording. That.